Angles of a triangle. All three angles of a triangle add up to equal 180 degrees. This is known as the triangle sum theorem. This image, we're given four different angles, Z, Y, X, and W. What angles add to equal angle W? W is known as the exterior angle. These two angles here add to equal the exterior angle. So we're going to write the measure of angle Z plus the measure of angle Y equals the measure of angle W. This is known as the exterior angle theorem. Now we're going to work a few problems that are associated with these two things. The first thing we need to talk about is similar triangles. Similar triangles are not just two triangles that look the same. Those are two triangles that have to have the same angle measurements. That's the requirement for the triangles to be similar. Not just one triangle is small, one triangle is big, but the triangles must have the same exact angle measurements in order for them to be considered similar triangles. So for number one, it says in the diagram, angle ABC trace A to B to C equals angle DEC, DE to C. So this angle and this angle, they don't give us an exact angle measurement, but they tell us that they're equal to each other. Explain how you know triangle ABC and triangle DEC are similar triangles. So this triangle is the big triangle. This triangle is the small triangle. How do I know that? I'm going to trace ABC here, here, and here, and DEC from D to E to C and back to D again. So we have a bigger triangle and a smaller triangle, and they want to know how we know they are similar triangles. Well, in order for triangles to be similar, like I said earlier, they have to have similar shape and size. But the key is the angles must be the same. And in this particular problem, they're just telling us these two angles are the same. So how do we know that the other angles are going to match? That's the question. And the key here is angle C. If you look at angle C right here, ABC and DEC. C is the key to this answer because both triangles include angle C. We know that they have two angles that match now. We know they have this statement here that says that these two angles match and angle C matches because they both include angle C. Well, if you have two angles that match, you only have three angles of a triangle, you know the angles must be the same. So we're going to write this down. Triangle ABC and triangle DEC are similar triangles because all three angles are the same. Now, that one statement is not good enough because they want to know, how do we know that all three angles are the same? So I'm going to add to it and say, I know the angles are the same because, for one, they give us this information, angle ABC is congruent to angle DEC, and both triangles include angle C. That's the key. Because both triangles include angle C, not only are these two angles the same, but angle C is also the same, which means this top angle here and here must also be the same, and they must also match, meaning all three angles are congruent to each other. Moving on. Number 2. Are the triangles shown in the diagram at the right similar? Use angle relationships to explain how you know. So, in a roundabout way, they're telling us, explain how you know they're similar. So they're kind of answering the question for us. So we're going to go ahead and write a statement saying the triangles are similar because the angles are the same. The triangles are similar because the angles are the same. Now, how do we know the angles are the same? Not just because they tell us in a roundabout way in the question, but we have to prove that the angles are the same. So we need to find the measure of angle B, E, and D so that we can see if the angles inside here match the angles inside of this triangle. So let's find B first. Measure of angle B. All three angles of a triangle add up to equal 180 degrees. That's a fact. So, I know I have a piece that's 70, a piece that's 65, and a piece that's missing. So in order to figure this out, we have to do 65 plus 70, which is going to give me 135 degrees. That's not my answer for the measure of angle B. That's how much is there already. So we have to find the missing piece. In order to find that missing piece, we subtract 180 minus 135, which gives us 45 degrees. So angle B is 45 degrees. Next, we have to find the measure of E and the measure of D. Why do we have to find that? Because we're trying to see if this triangle's angle measurements match this triangle's angle measurements. So far, 45 and 45 match, but we don't know if these two match 65 and 70. So, this whole measurement right here is 180. How do we know that? Because the line is 180 degrees. So I'm going to say 180 minus the piece that I have. That's going to give me 65 degrees. So I know E, the measure of angle E, is 65 degrees. Again, I got that by saying a straight line is 180 degrees, and knowing that it's 180 degrees, if I know a piece of the line is 115, you just subtract to find the missing angle. D, I have this angle measurement, and then a missing angle measurement. all three of these angles add up to be 180 degrees. So, just like I did for this problem here, I'm going to add up 45 plus 65. 45 plus 65 is going to give me 100 and that's going to be 110. So I need to take 110 and subtract 180 from it. And when I subtract, I get 70 degrees. So the measure of angle D is 70 degrees. Now, how do we just prove that the angles are similar? We found that this angle is 45, 65, and 70. This angle is 45, 65, and 70. And because the angles match each other, it doesn't matter the size of the triangles, but because they match each other, that is what proves that the triangles are similar. Moving to number 3. Number 3, the hint for number 3 is that these two lines are parallel lines. So I'm looking at those and thinking about the vocabulary from last week. Vertical angles, alternate interior, alternate exterior, corresponding, same side interior, same side exterior. All of those vocabulary words come into play here because these two lines are parallel lines. So finding the measure of angle A is actually pretty simple as long as you remember one specific vocabulary word. The measure of angle A is the measure of angle A is 55 degrees because these two angles are alternate interior angles. So it's 55 degrees because of alternate interior angles. Because these are alternate interior angles, they're going to be the same exact measurement. So that is also 55 degrees. Now, finding the measure of B. There are two different ways to find the measure of B. I'm going to use the triangle method because we are on triangles this week. Last week, we worked this problem and we actually used alternate exterior angles, found that this angle matched this angle, and we went from there. But this week, and today, I want to use the fact that this is a triangle. And if I know that's 55 degrees, and this is 65 degrees, and I'm missing one piece, we can figure out that missing piece. The way we figure out the missing piece is by knowing all three angles of a triangle added to be 180 degrees. So 55 plus 65 is going to give me 120. And then I do 180 minus 120. And that's going to give me an answer of 60 degrees. So the measure of angle B is 60 degrees. Now you can always check this. What is 60 plus 55 plus 65? And the answer there, when you add up all the angles of the triangle, you get 180. If you check it and you're over or under 180, then some of your math is not correct. That's an easy way to make sure that you have the correct answer, is to check all three angles at the end of the problem and to make sure that they all add up to equal 180 degrees. All right, number 4. In triangle ABC, angle B, right here, measures 30 degrees. And the this is very important. Angle A equals angle C. So they're only giving us one angle measurement, and they're asking us to find A and C, but that piece of information that A and C are equal to each other is very, very important. So again, for probably the 10th time, all three angles add up to be 180 degrees, and I know a piece of the triangle already is 30 degrees. So my first step is 180 minus 30, and that's going to give me 150. Now we're looking for measure of angle A. Well, the measure of angle A is not 150, because angle A is equal to angle C. If we say angle A is 150, then C is also 150, and that's 30. Well, 150 plus 150 plus 30, that's 330 degrees. That's not possible. So we have to figure out a way to split that value. How do we split something in math? We divide. So we say 150 divided by however many we're splitting it by, which is in this case 2 angles, and 150 divided by 2 gives me 75 degrees. So the measure of angle A is 75 degrees. Again, you can check that, and it's very easy to check. If A is 75 degrees, we know B is 30, we know C has to be the same as A, which is 75. Quickly add them all up, and you get 180. So it meets all the criteria of this problem. B is 30, and these two angles are equal to each other. Number 5. Are triangle PQR and STU similar? Explain. So we don't know if they're similar or not. We have to figure it out. Well, first thing I want to do is off to the side, I want to write down the order that they write these letters in, PQR, STU. In order for these to be similar, we know P and S have to be the same exact measurement, Q and T have to be the same measurement, and R and U have to be the same measurement. And we'll check that at the end of the problem. What we need to do first is actually solve it out by finding the missing measurement. You cannot just look at this problem and say, oh, look, different measurements, not similar. That's the shortcut, and that does not get you the correct answer. First thing I see is Q and T. That's 105 degrees. So far we're on the right track. Q and T actually match up, and they're both 105 degrees. Next, I need to find the missing angle P here and the missing angle U. So let's focus on this triangle first. I have 105 and 40. So I'm going to go 105 plus 40, and that is going to give me 145. That's, again, that's not our angle measurement. We actually have to do that next step of subtracting by 180. And here's where we get our angle measurement of 35 degrees. So we say the measure of angle P is 35 degrees. Does P and S, are they both 35 degrees? 35, 35? Yes, they are. So let's do the last little piece to check and make sure we're correct. I'm going to find this missing angle measurement here by doing 105 plus 35. 105 plus 35 gives me 140, and 180 minus 140 gives me 40 degrees. So the measure of angle U is 40 degrees. Is R 40 degrees? Yes. Is U 40 degrees? Yes, it is. So they are similar. because the angle measurements are congruent to each other. And we're going to write that as a statement because it's telling us to explain right here. So we're going to go back to the top and say triangle PQR and triangle STU are similar because the angle measurements are congruent to each other. They are congruent to each other. Now, this last problem is a challenge problem, meaning it's a little bit tougher than what you'd see on one of my quizzes or maybe even the LEAP test. But it is something very good to discuss and think about. So it wants us to find the values of x and the values of y. So we have to do two separate problems here. So we're going to separate this by, say, solving for x here. So we'll solve for x first. And then on this side, we'll solve for y. Just so we can distinguish which problem is which. So the first thing we're going to look for is x, this piece here. And in order to do that, we're looking at this triangle here. So we have 40 degrees given to us, and 90 degrees given to us, 35 and x, and we'll talk about that in a second. Right now, I want to discuss 90 and 40. If I know 90 and 40 are given, and I'm trying to find this missing piece right here, I would say, what is 90 plus 40? Well, 90 plus 40 is 130. And again, 130 is not my answer. I have to take that and subtract it from 180 because all three angles of a triangle add up to equal 180. When I subtract that, I get 50 degrees, which means this whole entire measurement here is 50 degrees. So if I know this whole measurement is 50 degrees, and I know a piece of it here is 35, how can I figure out what x is? Well, one last step is to say 50 minus 35 gives me 15. So x is 15 degrees. And again, you can go about checking that by saying, what is 15 plus 35? And you get 50. Then 50 plus 90 plus 40 will give you 180. Next, solving for y is very, very similar. You have 90 degrees here, so I'm looking at this triangle. So I have 35 that I'm going to use. Don't use 50 because we're just looking at this piece right here. Because we're going up to this triangle. So we're using 35 and we're using 90. And I'm adding that together. Well, 35 plus 90 is 125. 180 minus 125 gives me 55 degrees, which means this measurement here, from here to here, this measurement, that is 55 degrees total for the whole entire thing. So if I know y and 40 make 55, then I do the same step I did here, except I use 55 and 40. What is 55 minus 40? It just is a coincidence. You get 15 as well. So, y equals 15. Again, test it out and make sure it's correct. Well, 15 plus 40 is 55, and 55 plus 90 plus this 35 here is 180 degrees.